All right, so here are the notes then for section 7.3 on the Pythagorean theorem. We're going to go through the answers here really quickly of these warm-up problems. So as you should have been able to figure out, you go through. If you take the square root of 1.44, you get 1.2. You can always check that again by multiplying the number you get by itself to get 1.2 times 1.2 equals 1.44. And then we're going to take the square root of 900. And since the plus or minus sign's out front, we have to bring that down with us. So once we get here, then that is the plus or minus 30. And then the last one, you've got a fraction. So you can take the square root of the top and the square root of the bottom, since they're both perfect squares, to simplify this. And if you end up doing that, you've got the square root of 4 over the square root of 9, which equals, as you can see here, 2 over 3. Okay, so that's pretty much all you need to know for square roots. Okay, so this section is going to be heavily involved with triangles. And some of you are probably wondering, well, what do we have to know about triangles for? But if we have a right triangle, guys, we can actually use the relationship between the two short sides that make the right angle and the longest side and use it to find unknown lengths. Okay. And I think that this is probably one of the more interesting things, because if you ever want to become like a carpenter or you want to just build things as a hobby, you might actually use this within your time, maybe outside of school. Okay, so when you have a right triangle, you have three sides, obviously. Okay, as you can see, they form together to make a right angle. How do you know something has a right angle? Well, it has that little mark there, right, in that little right, it's a square, basically. You have that inside. Okay, and what we're going to call the two short sides, they actually have they have a funny name here, but what we're actually going to call them first is we're going to give it a letter. We're going to call it A. We're going to call the other one B. Okay, those are the two shortest sides. Those are also known as the legs, and I'll write those up in the top right corner here in just a second. So the two angles, or the two lines that make the right angle, are the legs. Those are the two shortest sides of your right triangle. No matter if it's, no matter what type of right triangle you have, the two shortest sides will always make the right angle. And then the longest side, which is on the opposite side of the right angle, is going to end up being, we'll call it C, but it's also known as the hypotenuse. And A and B, like I said, are going to be called the legs, and C is known as the hypotenuse. Okay, it's not really that important that you know the names of what we call C and A and B. Just understand that the two shortest sides are A and B, and then the longest sides are going to end up being, the longest side, excuse me, there's only one, is going to end up being the hypotenuse, so C. Okay? All right, and then the formula itself is going to be A squared plus B squared equals C squared. And there's actually a relationship here, you guys. If you take the shortest two sides, you square them, okay? So you multiply them by themselves, and then you add them up, it will equal the longest side squared without having to measure it. Okay? So it's actually pretty useful. If you're not able to measure something, you can just take A squared, add it to B squared, and then take the square root, and then it'll end up giving you that side. So we have this triangle here, okay? It's a right triangle because of the fact that it is a right angle in the corner here, okay? So what we're going to do first is we're going to label the sides that we actually know, okay? And we know that the two shortest sides come together to make that right angle, all right? And the two shortest sides are 5 and 12, okay? And again, guys, you can say that either 5 is the shortest one, and again, it doesn't really matter. You can just label them A and B. You can call it B or A, doesn't matter. As long as the two shortest are A and B, that's all that matters, okay? So if we say that's A, then 5 is going to be represented as A, B would be 12, and we don't know what C is, okay? So we're going to use the Pythagorean theorem to figure that out. And again, the Pythagorean theorem is a squared plus b squared equals c squared. And we're going to just simply plug in the numbers for the variables in the equation. So we only know a and b, so that means we can't plug in anything for c. So we're going to solve the Pythagorean theorem equation for c. Okay, so we'll just write 5 squared plus 12 squared, because a was 5, b was 12. Now we're going to square them. Okay, so you do 5 squared. The reason why we square them first, again, because the order of operations says exponents come first. So don't add 5 and 12. We're going to do the exponents first, then we're going to add them. So 5 squared is 25, and then 12 squared is 144. So you got 25 plus 144, that's going to equal c squared. Okay, because again, we don't know what c squared is. We're trying to solve for that now. Okay, now that we have the two numbers, we can add them up because there's no more exponents. And when we add them, we're going to end up getting 169. Okay, so you get 169 is equal to c squared. Now, if c squared equals 169, how can we figure out that what c just equals? Well, we just learned about square roots, where we undo a square by taking the square root. And if we do it to one side, then we have to do it to the other. It's just like the golden rule of algebra that we talk about at the top. So we're going to take the square root of the right side, and we're going to take the square root of the left side. So all that should be left after you square, or take the square root, of a square should be c. Okay? And then you take the square root of the other side. So the square root of 169 is going to be 13. And you guys should know that from your perfect squares list. Okay? So again, all we're doing is we're taking the two sides that we know and finding out that missing side by using the Pythagorean theorem, a squared plus b squared equals c squared. Okay? So what I'll have you do now is, if you guys want to pause the video and work on some of the problems here that we got coming up. So pause right now if you want to go ahead and do the video. Otherwise, we'll get started here on problems 1 and 2 for the examples, okay? So we'll just go through these here. I'll kind of talk through the answers, and then you guys can take the notes so you have those in your notes, all right? So two shortest sides, 8 and 15. So we're going to label those A and B, because again, they come together to make that right angle. So again, since we use the Pythagorean theorem, it's a squared plus b squared equals c squared. So we replace a with 8, we replace b with 15, and we still have c squared. Now we just have to square the numbers, because again, we have to do that first. So 8 squared is 64, and 15 squared is 225. Then we add them up to get 289 equals c squared, and then we take the square root of both sides so that we can get an answer of 17. Okay? I know I went through that really fast, and again, since we are talking about a real thing here, let's make sure we put that label on. We've got c equals 17 feet. It's the same process over and over again, guys. It's really simple, okay? So just understand that when we go through here, you're not trying to reinvent the wheel. You're just plugging in numbers that you already know, okay? So let's go and try 2. This one's a little bit more complicated, but you guys should be able to figure it out as far as using your knowledge of fractions. So again, two shortest sides, 3/10 and 2/5, A and B. So we're going to plug them in. We're still going to square them, okay? All right, if I'm running out of room here a little bit, that's supposed to equal c squared, okay? So when we square fractions, we square the top and the bottom. So we're going to do 3 squared over 10 squared. And then that ends up equaling 9 over 100, okay? So we do 3 squared, 3 times 3, 10 squared, which is 100. Then we do 2 squared, which is 4. And then we have 5 squared, 25. And that still equals c squared. Now we have fractions, common denominator. Common denominator that we can use, well, we have 125, so we can change this fraction. Since it was over 25, we multiply 25 by 4, so then we multiply the top by 4 and get 16. So we have 9 plus 16, as we add the numerators, over 100 equals c squared. But as you guys know, we can simplify that too, right? That simplifies all the way down to 1/4, because if you have 25 cents, out of $1, you have 1/4. So it'd be 1/4 of $1, and we could rewrite that fraction here, which we'll do. So that ends up equaling 1/4. If c squared equals 1/4, though, I want to know what c is. So to undo a square, we're going to take the square root of each one. So we take the square root of the top, which is 1, because 1 times 1 just does equal 1. And then we're going to take the square root of the numerator, which would be 2. All right, guys. Now, what happens if we only have one of the legs and we actually get the hypotenuse? So we get c this time, but we don't know one of the other ones. So for this example, we're given b and c. We don't know what a is. Okay? So we're going to write down, we got a, we don't know. B is 2.1, and c is going to be 2.9. Now, we don't just change the Pythagorean theorem just because we're only given a and b. Okay? Or sorry, we're only given b and c. But what we can do is we can just replace what we know. So we're only going to put in b and c. We're going to leave a by itself. Okay? Or so we want to solve for that. So we still plug in our numbers. We're still going to square everything. Okay? So we have a squared, which is not going to change because we don't know what it is. So it still stays as a squared. Okay? So then you take 2.1 and you're going to square that, and then you get 2.9 and you're going to square that as well. And you should get 4.41 after you square 2.1. And then 2.9 squared is 8.41. Now, since we're trying to solve for a, we're going to undo the operation. So the opposite of adding 4.41 would be to subtract it. And as you can see, that makes a 0. So then we get a squared is equal to 4. And then we take the square root, just like we did before. Okay, so then we get a is equal to 2. All right, and then that side would end up working if we did it the other way. And since it's the centimeters, let's make sure we add that label to it, and we're good to go. All right, so again, guys, it doesn't change even though we only know b and c. You're just solving the equation for the variable that you don't have. All right, so we've got this real life example now. So this would be something that you would maybe see on a 4 on an assessment. Okay, so teams playing capture the flag. You're 50 yards away from 50 yards north and 20 yards east of your base, and the other team's base is 80 yards north and 60 yards east. How far are you from the other team's base? So you can see we have a triangle here. Okay, they give us the legs. It's 30 and 40. So we'll say A is 30 and B is 40. We're still going to use the Pythagorean theorem because we don't know what C is. We're trying to see what the diagonal distance would be. So we just replace A and B with 30 and 40, and we're still going to square it. And 30 squared does actually equal 900, and 40 squared is not 2,500. That's actually the sum of what you're going to get here shortly. It's actually going to be 1,600 equals C squared, and we add them up. Then you get 2,500. And then we're going to take the square root of both sides, and C is going to end up equaling 50 yards. Okay? So guys, like I said, it's not any different than what we just did before. We added a couple of words to it. We talked about capture the flag, whatever. It's still A squared plus B squared equals C squared. It's the same stuff that you guys have done in the last couple of slides here, okay? So if you want to pause the video right now and try these examples on your own here, you go right ahead. Otherwise, I'm just going to go through here and go through the answers and solutions to both of these problems, 3 and 4. We're going to skip 5 because it's not really important as far as getting the information across. But so we know A and we know C this time, okay? B is not labeled, so we're only going to use A and C for the numbers. So we're going to plug in 16 for A, and we're going to plug in 34 for C, and we're going to solve for B. So we're going to square both numbers. So you get 16 squared, which I got to check here and make sure I got that right here before I write it down. Okay. And that's going to end up equaling 256. And then 34 squared is going to be 1,056. Okay. So again, solving for B. So then we're going to undo plus 256. So we'll subtract it. And we'll end up getting B squared. Actually, I'll write my stuff up here. B squared equals 900. And if we take the square root, we should end up getting b to equal 30 yards. Okay, so that's the answer to number 3. Now let's get on over to 4. And guys, don't be discouraged by decimals. Decimals they're not scary. Okay, you guys can do it. All right, so we don't know A, we know B, and we know C. So again, same process. Plug it in for what you know. All right, so I'm just going to divide here so you guys can see. So we got A squared, we don't know. B is 9.6 squared, and C is going to be 10.4 squared. All right, so again, square the numbers first, and then we'll worry about subtracting them in a second here. Okay, so type in your calculators. You guys are allowed to use calculators on the Pythagorean theorem stuff. So you're going to take 9.6 and square that. So you get A squared plus, let's figure out what that is. And it's going to be 92.16. And then if you take 10.4 squared, you should get 108.16. And then we're going to subtract 92.16 from both sides. We should get A squared is equal to 16. And then we'll end up taking the, we'll end up taking the square root of 16 to get A is equal to 4, and that is 4 meters. All right, guys. Make sure that you do the spiral homework for this section, and then also the big ideas 7.3. These will all be due on Monday. Okay, get those done. Thank you.